Hello, welcome to another Geometry Nodes tutorial. I've been reading through the comments here on my channel and people still watch older videos and they still have questions about those. And one video in particular, maybe you remember this one, where I made some sort of Frustum culling, camera culling effect using Geometry Nodes, but that was done in the old version of Geometry Nodes with the attribute workflow. So people keep asking, how about doing the same thing with the fields Geometry Nodes? So in this video, we're gonna take a look at exactly that. Here I am in Blender 3.1 Alpha. I have a very naked scene here with just a little backdrop object here. And with that object selected, we're just gonna jump right in, go into Geometry Nodes, create a new node tree. So this is our stage object. And first of all, let's put some points on here. So we need to distribute some points onto this geometry. But of course, we also want to see the stage. So we have to join it with our original, and that's it. So now we have points. Okay, so the way this is going to work is we will emit some rays from those points towards our camera, and then we're going to have a lens object in front of the camera, and whatever ray hits that lens is inside of that cone of that frustum, viewing frustum from the camera, right? And those are the points that we actually want to have something rendered onto. What are we going to render? Let's just put in a, you know what? Let's do a Shift A. Let's create a monkey head. Why not? And move that out of the way. So on here, we are going to instance onto the points. We need to get input object info. We need to eyedropper in our monkey, and that's the geometry we want to instance. So now we have a whole lot of monkeys. Let's scale those down a little. Okay, that looks pretty cool. Maybe even smaller. Let's go into edit mode here. Move that so that the origin point is right under the chin, so we can see what this looks like. So they're all sitting on the surface here. So now we have monkeys on our surface. Oh, my camera has a depth of field set to it. Where is my camera? Here. Let me switch that off quick. So now we have this. Okay, so we can see I have a square camera in this case. So my output resolution is set to a square thing. If I move my camera in like that, you can see we're rendering all of these for no good reason because they're outside of the camera's field of view. And that's what we want to get rid of now. So let's go back here. Okay, we need the special node that is the Raycast node. Let's put that in here. And when I saw that node, I thought, well, how is this going to work? The Raycast node needs two pieces of geometry, one to emit rays from, and then one to possibly hit a target, right? But we can only plug in the target geometry. So this is really the cool or crazy thing about the fields system of Geometry Nodes, because I've explained this in other tutorials here on the channel before. This node takes the input, takes the source geometry for this node comes on the right side, right? So whatever you plug in here, this is where the rays are being emitted from. So maybe this becomes clearer if I plug that into here. So what's happening? We have points, right? So we're plugging points in here. If I hover over it, we have 766 points in this point cloud that we generated. And those points are now being used in this node to cast rays. And those rays are pointing in a direction. Right now, they're all going straight down. So let's switch that off. Let's go, I don't know, somewhere else. First of all, we need a target geometry. I've done this before in the other tutorial. I'm going to do it here again. We need some sort of lens object that those rays can hit. I'm going to create the lens object now manually, but I'm going to show you how to create this procedurally in Geometry Nodes. So let me just shift a plane. So now I have this plane here. I'm gonna move it here. This is my camera. Move it there. Go into edit mode, scale it down, rotate it, and just make it sort of fit my camera here. Okay, so it looks like this. And from the top view, is this already pretty good? Yeah, it looks pretty good. So here we can see that square. Okay, of course, if you don't have a square resolution, you need something like a rectangle. But now I have this square. This is the square, the lens of my camera, that those rays from these points here have to hit in order to be included in my selection. So target geometry, I need to put in this lens object. So let me just get that. I drop that in. It's called plane. Let me call it lens so we know what we're talking about. Lens, geometry, hit. Okay. And I'm going to disable it here. Otherwise we can't see anything because it's in front of the camera. So that thing is there. The rays are being emitted. Right now they're not, but let's just plug in -1 on the y-axis. Oh, and also we have to switch this to relative because the camera, of course, has a location. And you can already see something is working. So these rays from this surface are being emitted -1 on the y, which is going this way. So we have a ray that's being emitted this way, and only the rays up here from these points actually hit our lens object. Okay, so this is already working. If I take my lens object, which I can't because I disabled it, but if I take it and if I move it, you can see it's already working. But of course, now we have another issue. All of those rays are being emitted in one direction. That's not good. We want all of those rays to be emitted towards the camera. So maybe this vertex up here needs to emit to this camera point, and this vertex down here needs to be emitting in this direction, and this one in this direction, and so on. And so, hold on, delete. Okay. So we need to plug in a direction. What's the direction? Well, let me copy this object again. Let's get the camera in here. And really what we want is a vector pointing from our point to the camera. How do we get that? Well, let's think about it quick. So this is our origin down here. And this point up here, or let's pick another point. Let's pick this point. So this point has this position vector, and the camera has this position vector, and the vector going from here to here, this vector, is just subtracting one from the other. That's really very easy calculation. So let's do that. We have the position of the camera. We have the position of the point. How do we get that? We need an input position. What happened? Input position. And we need a vector math. Subtract the location of the camera, the location of our point. Now this is an attribute and it's coming from our points here. So again, here we have the points, and these points, how can I move this so that we can see the noodles? Okay, so these points are now being used in here, and this position is actually the position of the point. Okay, so this is now the ray direction. So now all of these points are emitting a ray in a very particular direction, which is exactly towards the camera. Now let me hide this lens object again. You can already see it's working. Okay, so we're only instancing where we're hitting our lens object, which is in front of the camera. All right, now, of course, the issue is I'm moving the camera, but I'm not moving this square here. I'm moving the camera. So this is, of course, not right. Now we could parent this lens object to the camera, which is what I think I did in that older video. But a much better solution is to create that lens object procedurally in geometry nodes. So let's get rid of the lens object. Let's go back here and let's create that lens object. What is it? Well, it's a square. So we can create a square with a mesh primitive grid, and we set the vertices to 2 by 2. So now we just have 4 vertices, and it is 1 by 1 meter. Okay, where is that grid? We can't see it. Let me just plug that in here so we can see it. Cool, there's the grid. But we need it up here where the camera is. So let us transform this and move it to a certain point, which would be the location of the camera. So let's move it up here. Now it's up here. Then we also need to rotate it same way that the camera is rotated. So now it's there, but it is now in exactly the same spot as the camera. We need it to be in front of the camera, right? Like the lens, so that the rays can hit it before they hit the camera or the sensor. So how do we move this thing out a little so that it is in front of our camera? Well, let's think about cameras real quick in Blender. If I go down here and I shift a new camera, where is it? Here. And I Alt R, which is reset the rotation. Okay, 0, 0. This is what the default camera looks like in Blender. It's pointing straight down, and then the upside, like where the flash would be on the camera, that's that little triangle here, that is pointing in the Y direction. So what we need is a vector pointing in the direction that the camera is looking at. Okay, we need a vector. So we need to put together a vector combine. It's pointing straight down, this thing. Okay, straight down will be this sort of vector. And when we rotate this vector, can we do that? Let me plug, where am I putting this? I need to rotate a vector. Search, rotate, vector, rotate. So this is my vector that I want to rotate a certain amount of degrees, rotation, Euler, and the rotation is the one from the camera. I'm running out of space here. Okay, rotation. So now I have a vector which is initially pointing straight down, then I rotate it in the same direction that the camera is looking at. So now I have a vector looking in the direction that the camera is looking at. Okay? And really, all I need to do now is I have this square here with 4 vertices. I have to move those 4 vertices in that direction. So I need a set position node, which has an offset input, and I'm offsetting my vertices in that direction. Cool. So what happens now if I move my camera? Yep, the square is moving with it. Awesome. It's always pointing to this track 2 point, by the way, this camera, because it has that track 2 constraint on here. So I just have to move and we get rotation and translation. But you can see that the square is always there, right? So now we have a procedurally created lens object. Now this lens object is obviously a bit big, but we can move it or scale it like this with these inputs here and just make it a little bit bigger than what the camera sees. So now it's this big, and we don't want to see this, and we just simply, we don't include it in our output geometry. So it's still there, but we can't see it. And now we can replace this lens input here with this generated lens input, and we have the same thing, but we don't need that extra object. And it always follows the camera because it's all done procedurally. So let me move this, let's organize this a little. Okay, here we need, this is our vector pointing down. This is the grid. This is the square. We're transforming it, we're setting its position, and then we're casting rays coming from our points. And this is our input, and this is our join at the end with all the monkey heads. All right, cool, that's the node tree. Now let me move the camera around a little. Let's see, let's go X. All right, this looks cool. Let's go in. You can see we're only ever instancing the correct amount of monkeys because we don't need the ones that are not even visible in the camera view. Now at this point, I have to tell you, on the last video, several people commented on YouTube, so what about reflections and shadows, right? We're missing those objects out here, so we can't see them in reflections because they're not there. We can't see their shadows. Well, if you need those, obviously, then this is not the technique for you. Just if you need all of them, render all of them. However, if you need shadows and reflections, do you really need them in like the super high quality? And what I mean by that is, let me go in here and let's just go back here to our monkey. So this is our Suzanne. Let's do this like that. And let's add a subdivision surface. Okay, so now we have that. Let's crank this up. And now we have very smooth monkey heads, okay? So those would be the super high resolution that we render inside of our viewport. But we want the reflections and the shadows from the ones out here that we can't even see now anymore. So why don't we just, to fix that, instance points the monkey, but without the subdivision, onto those same points, right? Everywhere where the selection is not a hit, so all of the other ones. So we need a, where is that? Utilities, Boolean math, yep. We set that to not. So we invert this Boolean and we want to instance low poly monkeys outside, high poly subdivided monkeys inside, and of course we have to add the outside ones here too. So now if I zoom in here, these are high poly, whoopsie, camera view, okay? And out here, they're very low poly. So now we get this effect. We get some sort of reflections and shadows, but we're only inside, we're rendering high poly monkeys. Of course, if you don't do it this way, maybe you want to render like a really simplified placeholder or something, then you just plug in a different object in here with a separate object info node. But this is the answer to what about the shadows and the reflections? This is how you do it. Of course, this is not necessary now, so let's, the whole part of this, the whole point of this tutorial is this up here. So let me just move that down here. This is our Frustum culling, which seems to work just fine. There's one thing left to do. You can see it's working really flawlessly, I have to say. If I go all the way back, we have all of the points. If I go all the way in, we only have a few points. There's one thing left to do though, and that is, let me show you something. I don't want to see this Suzanne here. If I go all the way forward here, pointing up, you can see something cool happening. See those down here? So the camera is looking up there, but we also get those points down here. Now, why is that? Well, I think I've explained this in the last tutorial. Because we have rays cast from the surface, or from the points on this surface, towards the camera. The camera is this point here. So we have a ray going here. And it's hitting our lens object in the front here. But we also have rays cast from these points to our camera. And they're long rays, so they also hit this lens object. So they're included in our is hit mask, basically. So how do we avoid that? Because that's not what we want. Well, we have to tell the ray. We can do that with the ray length, basically. Because these rays hit the lens and then reach the camera. These rays reach the camera first and then hit the lens. So we can change our ray length here on the Raycast node to just be the length of the distance between the point and the camera, right? So if the ray is only as long as it needs to be to hit the camera, if we're coming from the other way, the ray ends basically at the camera and doesn't even hit the lens object, which is further away. So we need to get the ray length, which is the length of this vector, because this is already the vector going from the point to the camera. So we need a vector math. There is a length option in here. Length of this vector goes in here, and then those points disappear. Let me mute this. Now let me unplug it, I guess. So now we still have those false hits, false positives. And if we cap the length of our array, then we have the perfect Frustum culling node setup. Okay, and the final thing to do is, this is our group input. Let me take that all the way over here. Now we probably, you can see we have the camera in here. We probably want to change that camera from the outside world, right? So we plug which camera in here. Also, I showed you in the size of this grid that we are generating here very much depends on the size of our camera or our final render. So if I switch this over to a 1080p, then we need to change those values here. We need to change the Y, it doesn't have to be that high. X, maybe a little higher, like that. So you probably also want to set the size X and the size Y from the outside here. And now this gives us a very nice reusable Frustum culling geometry nodes node tree that we can reuse if we have a different camera. So let's just try that real quick. This would be the geometry node setup. Here we have these things that we just piped to the outside world. So if I take this camera, GC, bring it up. Let's look through that camera. That's looking straight down. Cool. So if I want to use that camera, I have to switch over to this. This is cool. And then I can just set my width and my height to match whatever camera I have. And there you go. Works beautifully. If I rotate this now on the X, it's working just fine. Okay, if you rotate, or if you make have a slow motion here, and some are flashing in, like if you look right down here, and if I rotate this slowly, this monkey appears while it's already in view, right? And really the only way you can avoid this is to go and make your Y bigger and just render like a bigger border around your viewport. And that is it for this tutorial. I hope you enjoyed it. I hope you learned something new. The Raycast node is really cool. And don't forget, it's kind of weird that it has geometry coming in from the right, and the target geometry that it's actually shooting its rays at is coming in from the left in that target geometry input socket. I will make sure to include this geometry node setup for the Frustum culling effect in an upcoming version of my Crispy's feature-packed startup file, which you can get from patreon.com/Crispy. Thanks for watching, have a good day, Crispy out.
Like and subscribe.